one of the ideas in this section is complex conjugates. I mentioned this yesterday, but I don't think we worked any problems. Oh, we did work a problem that had one in it, and we multiplied it out. We saw that a whole bunch of ugly radicals all of a sudden turned out to be nice, or it had radicals with i's in it, and everything turned out to be a nice whole number. And that's what happens when you use these conjugates. Conjugates, they're in a difference of two squares pattern because that's how we usually use them. We're studying them right now and writing them just to practice writing them. But normally you use them to clear up ugly things in math. We've used them in calculus several times this year to make functions look a lot nicer. And they also give us nice answers. We'll see with some of the stuff we have to do today what they look like. So you're basically, a conjugate is making this difference of two squares pattern. So if I look at one, like we'll look at a straightforward one, number 39, it's more straightforward. If I have negative 6 minus the square root of 5i, and I want to make its conjugate, I'm not worried about changing. Here's where people usually get messed up. I'm not changing this, and I'm not changing this. So that negative out front's okay. It's not going to change. To write its conjugate, what I'm going to do is write negative 6 plus the square root of 5i. I'm just changing the operator sign in the middle. And a lot of people, I notice on tests and quizzes, will get that mixed up, and they'll think they got to change the negative out front. So this is a really good one to look at. So you would look at this as a minus b, and what I've written over here is a plus b. Okay, so that's what you're trying to do. You're not trying to change the sign out front there. You're trying to change the operator in the middle. Okay, so let's look at a couple more of these. If I were wanting the conjugate of square root of negative 20, if you write that in standard form, it would be, okay, now let's go ahead first and write it in standard form. It's kind of hard to think about the conjugate when you got the square root of a negative number. This would be the square root, let's go ahead and just simplify it first. The square root of negative 1 times the square root of 20, which is I, and isn't 20, doesn't it have in it a perfect square 4? And 4 times 5 would be how I'd break that down. So I could break out the square root of 4 is 2, and I got an I out front, and I got that I from that square root of 1. And then I got the 5 left in the radical, right? Can't get my words out. Now usually if you're going to write the conjugate, it would be more helpful if I wrote it this way. 2 square roots of 5i. A lot of times we don't like writing the I after the 5 because if we accidentally make our radical sign kind of float off, you know, it might look like the I is underneath. So you need to make sure you write it where you know the I is not underneath the radical. If I were to write this in standard form now, it would be 0 plus 2 square root of 5i. So how would I make the conjugate of that? If this is a plus b, how would I write a minus b? What would that be? If I'm just changing the operator sign in the middle, what would I write here?
0 minus 2.
Good. Good. 0 minus 2 square root of 5, and then the I is on the outside. And probably we wouldn't write that. I mean, if we were going to use that somewhere, like if we were going to try to make a denominator that was all, maybe it had 2 square roots of 5i in the denominator, and we were trying to clear that up a little bit, we would probably just write negative 2 square roots of 5i, unless they tell us to write it in standard form. The only reason I changed it to standard form is I would miss these all the time when I was, you know, doing this section in school, because I would get confused about, like on number 39, I would write 6 minus square root of 5 as my conjugate on 39, because I would be thinking you had to change the sign out front, and that's a real common error people make. And on this one down here, it's just like you look at it and you think, well, what am I supposed to do with that? You know, when it's just a radical, it's usually just change the sign out front, you know, and it's just one term, like this one. If you think about it, this was just, the conjugate was negative 2 square root of 5i, and remember that's just negative square root of 20i. And if I put the I back under there, which I could, remember I could have written this as just negative square root of negative 20 out front. But usually, if I were working in a problem, I might prefer to leave it like that. Let's think about, let me show you why. over the square root of negative 20. And I was trying to clear that up. I would probably, first of all, if I had, think about it, a simpler idea here. What if I had 1 over square root of 3? How would I clean that up? When I, like, say, I had another square root of 3, that would get rid of the 3 in the denominator, the square root in the denominator. Remember, we're getting rid of radicals of the denominator. We've done that before. But if I do it to the top to keep the fraction equal, I have to do it to the bottom. So it would reduce to square root of 3 over 3. You're going to be doing a lot of that when we get to trig because of just the way the trig functions fall out that we're going to do. Up here, probably, I wouldn't even worry about a conjugate. If I had something like this and I were trying to simplify that fraction, I would probably just multiply by the same thing. Isn't that what I did down here? Then I just multiply square root of 3 by square root of 3. So up here, I could do the same thing. I could multiply by, if I did the bottom by square root of negative 20, I need to do the top by negative square root of 20. So I actually should have had that up here too. You don't use the idea of conjugate so much when you just got a single term and a radical. You can just usually multiply by the radical again to get rid of it. But you're going to get stuff eventually that look like this. You might have 2 minus 3i. To get rid of it, to get rid of the i's altogether in the denominator, what you have to do is multiply by the conjugate to get rid of it. This is how you're going to use it eventually, okay? That will turn the bottom into 4 minus 9i squared, which would be 4 minus 9, and I squared is what? Do you remember? I is the square root of negative 1. I squared is negative 1, okay? If I multiply by the conjugate, and again, since I did it to the bottom, I need to do it to the top, but I'm just focusing on the denominator right now. Look what happened to that. I get 4 plus 9 is 13 in the denominator. A whole lot better looking than 2 minus 3i, right? You're never supposed to leave radicals in the denominator. You're really not supposed to leave i's in the denominator when you're working with them. So if you use the idea of conjugate, what happens in math is you get nice whole numbers, instead of where in places that used to have this weird looking stuff, okay? So that's how we use them. It's hard with a single radical when you're doing the conjugate though. You'd really, if I were trying to simplify that fraction, I wouldn't need the conjugate. So you don't really use the idea of conjugate with single radicals, but they gave you that example anyway just to get you to think about it. So that's why when I had what I had up there before, I actually wrote it in standard form first so I could think through it, just because it's easy to get that one wrong. Let's do it clear as mud. I'll do 42. It's not assigned, but the square root of negative 13, if I wanted to write its conjugate, I could write it in standard form. It's going to end up being the negative square root of 13, which is what confuses people on the normal ones. So that's why I said, okay, if you want to kind of keep from getting confused here, write it this way. 0 plus square root of negative 13, and so the conjugate would be 0 minus square root of negative 13. There's your a plus b. Here's your a minus b. All you're changing is the sign in the middle, okay? The ones, I'm going to do another one that's not assigned just because this is something a lot of students just get wrong, and I know I did, okay? If I had this one, if this is my a plus b, and the conjugate would be the opposite one, a minus b, in the difference of two square patterns, what would the conjugate of this one be? Good. It's not hard if you know how to break it down like that. Put it in standard form and just change the operator sign. But a lot of teachers never tell you that's really how they're figuring out the answer, and they just go, oh, if it's a radical, stick a negative out front. And if it's not a radical, change the sign in the middle, and then you get all confused. It just can be a confusing thing when you're working through problems. Go back and try those on your own. Make sure you check your work on those odds, okay? One more, just to quickly go through several examples. 3 minus the square root of negative 2. What would be the conjugate of that one? 3 plus the square root of negative 2. So it's not a hard idea. It's just you're going to use it a lot later. Maybe not right now, but you'll use it a lot later, and you just want to make sure Usually you got two terms, so it's easier to figure out than these single radicals up here.